Okay, fine. So our subject is power electronics and instrumentation. We basically deals with some of the semiconductor devices or components. So the semiconductor devices and components, if you say, basically it starts with your resistors, capacitors, inductors, all are basically made up of semiconductors. You know what you mean by semiconductor. Okay. So afterwards, diodes, transistors, in integrated circuits like ICs have come into picture. In ICs, we are going to have the digital logics like AND gate, OR gate, NOT gate, everything is there. And with that one, further improvements has come into picture like op amps, operational amplifiers has come into picture. Then you will be having 555 timer. These things is how the technology has evolved. What are all the different devices they could have manufactured with respect to semiconductor devices? Okay. So previously, when we did our education, at that time we were having tubes, vacuum tubes, like your bulbs. What we are going to have the bulbs, no? Like the vacuum tubes were there. In the vacuum tubes, anode, cathode, all those things they were using. From the anode, they used to give the power supply. Cathode used to catch that one. Everything is now the same thing has been designed using semiconductor devices like your diodes. In diode, we are going to have the anode and cathode. Correct? No? Even in transistor, it's a three-terminal device has come into picture. So collector, emitter, base, or collector, base, emitter, which are the notation. Then after transistor come into picture, then it has changed to UJT, BJT. What is UJT? Unijunction transistor. BJT? Bijunction transistor, will call that one. So these are all the devices which is manufactured with respect to semiconductors. Okay, semiconductors. They are not fully conductors. They are not insulators. Fundamentals. You know what I mean by conductors. What I mean by semiconductor. What I mean by insulators. Okay, there is a forbidden gap will be there. Valence band, covalent band. All those things you are studying in your basic physics and also basic electronics. So I don't want to explain put much effort on that one. Already you have studied. Now our interest is how exactly is semiconductor devices like your thyristors and also UJTs. Thyristors and UJTs are going to work. So with respect to the syllabus, when you look into this is the first module. In that one, they have mentioned what is anode, cathode, static anode, cathode characteristics of a gate and gate characteristics. There will be a gate characteristics, silicon controlled rectifier. Then how exactly we can turn on them and turn off them. When it is turning on, means when the device is turning on, what's going to happen? When the device is turning off, what's going to happen? We are going to measure that one. So characteristics comes into picture. Just like diode characteristics. After some time, that is your germanium and silicon. Germanium diode and silicon semiconductor devices will be there. No, both of them will be at different points. Okay, like 0.7, 0.3. Okay, you might have heard about that. So based on that, the characteristics keep on changing. If you are using germanium diode, it's going to be different. If you are going for silicon, you're going to get different characteristics. Small slight change will be there. Those things I've already shown in LUST projects also. Or I've used one more tool, ARCAD tool. There are two tools are available. One is LUST projects, that is online. It's available online. All my circuits can be rigged up and I can execute them. Second one is a downloaded software where you can download in your laptop and you can design the circuit on your own and you can execute them. In one class, I have executed rectifiers. How exactly rectifiers is going to work? So in our syllabus, we will be knowing the characteristics of the SCR, characteristics of the thyristor, on mode, off mode, turn off mode, turn on mode, and what are the turn off methods, what are the turn on methods, everything we are going to learn. So that is what there in the syllabus which is given. Here, turn off methods, turn on methods, turn off mechanisms, different mechanisms we are going to have. natural and forced commutation, naturally how it's going to work, or forcibly how it's going to work. Sometimes naturally there's a triggering comes into picture. As soon as you give the power supply, there's a natural triggering. With the given power supply, it's going to trigger. Vehicle, no? Some comments on this. Just 1 second. So, without spending much time on this is the syllabus of the first module and outcome. Very, very important. You should know the outcome of the particular module. This is with respect to VTU syllabus. With respect to VTU syllabus, VTU only has defined that one. What is the outcome of this particular module? The outcome of this particular module is how we are going to understand the silicon control rectifier. The silicon control rectifiers, what we are going to understand. Major characteristics of the SCRs. Then also UJT, unijunction transistors, we are going to work over there. Understanding the SCR and UJT with different triggering conditions. That's what I am telling. It is naturally it's going to operate or forcibly it's going to operate. Forcibly in the sense you are going to apply some inputs. Some extra inputs you are going to apply. If I am giving different inputs, or maybe I may apply some different input resistance. Assume there is a road. Normally you can go there. With a normal speed you can go. That is normal condition. If there is any obstacle, if it is placed, obstacle they place over there. Maybe road hump. As soon as you put a road hump over there, immediately you are forcing them to break down, means to slow down. To slow down. Or if there is any deviation, assume that means some deviation. There is some construction work is going on, you want to deviate them itself. So like this, even in circuits also, electronic circuits also, natural operation is different and forcible operation also is going to be different. You are forcing them to get deviated from the natural operation. That is also we are going to learn in this particular topic. Moving ahead, resistance, capacitance, circuits and all you are going to use that. Let us not worry for that part. Now, coming into the topic, this I told you many times, I have projected this slide last 2-3 sessions also. Basically, our power electronics, it deals with the 3 different terms. 3 different terms. First one is the electric power, second one is the electronics, and third one is the control systems. These are the 3 terms basically we are going to deal with power electronics syllabus. You know that one power. Generally, any electrical or electronics circuits, if they want to operate, they need a power. Without power giving to them, it will not operate at all. Simple example is your mobile or your wristwatch or your smart watch, whatever you are going to call it. Smartwatch need to be charged. Anyone having smartwatches? Have you heard about smartwatch? Is there? Whether the charger is required for that? Yes. Okay, don't worry about the smartwatch. Let us come to your headphone, boat. You might have heard about that one. It's a simple electronic device. Simple circuit, very small circuit. Bluetooth it's going to work. Okay, it's Bluetooth. So what it's going to be? It needs to be charged. It needs a power supply. Electrical devices needs larger power supply, but electronic devices need smaller power supply. Very small, like 10 volts, 20 volts, 5 volts, 3 volts, like that requires. But electrical appliances like your grinding machine, mixer, or washing machine, they need larger power supply for them. 230 volts power supply. Your fan, there is a difference is there. For tube lights, you need 230 volts power supply. For LED lights, not required. For LEDs, DC voltage is sufficient for them. Okay, so power plays very important role in electronic circuits. Without power, we cannot work at all. There should be some power. Either it may be a battery power or stored power storage. You may have stored the power. It's like a your cell which is there in your wrist watches, okay, or battery which is there in your mobile, or battery which is connected to my laptop. Okay, they are getting some power stored over there. Using that power, they are working over there. Second thing is electronics. The word called electronics because nowadays everywhere we are finding the electronic devices. Everywhere. All my automated operations, what all is happening, without electronics, they will not work at all. If you say automatic alarm clock, automatic washing machine, refrigerator, TVs, electronics is required. Electronic car, that is EV cars. Basically, the electric vehicles, they'll call that one. They need electronics. They need semiconductors. They need all this, what and all the topics we are going to discuss in the entire syllabus, they need that. So electronics plays very important or very major role in almost all the recent and current and in future activities also. And last one is control systems. Do you need a control system for your vehicle? Do you need a control system for your washing machine? Do you need a control system for your water heater? Everywhere control system is there. There is a, if you go to the shopping mall, there is a water heater, electric water heater, where you can heat, you can boil the water in that. Or electric iron. Simple example, electric iron, electric water heater. So even though if you're giving the continuous power supply, there is a threshold. Up to the threshold level, it's going to take the power. Then it's going to automatically switch off the power. Automatically switch off the power. It will not take the power. Electric water heater basically. Even your electric iron also, you are giving a continuous power supply. Depending on the type of the cloth, it will see to that what is the heat generated. Then automatically it will switch off that one. So who is taking care? A control system which is available in that particular electronic component or device, it's going to take care of it. So all our household electronic components or circuits or devices or equipments or gadgets, whichever the word you are going to use, they will be having a control systems. So now there is a floodgates. Floodgates, you might have heard about that one. Water falls, there is a gate is there, they are going to close. They are also automated. They will also automate it. There is a control system is there. Control system will take care of that when it has to open, how much it has to open, when it has to be closed. Everything is automated. So control system, electronics and power, these are the major three words what we are going to learn, what we are having in the current scenario. Power engineering deals with the static and rotating power equipment for the generation, transmission and distribution of the electric power. Very important. I told this long in the previous class also. Whenever you say power, power is required for your operation. And we are facing some issues with the power generation. In today's paper, yesterday's paper, you check it out. The headlines only, they have put that one. There is a lot of scarcity with respect to coal. A coal which is required to generate the power, thermal power. RTPS, Raichur Thermal Power Station, we call that one. Raichur Thermal Power Station, RTPS, is there in Raichur. They are generating the power with respect to coal, using coal. But coal mining, because of scarcity of coal, they are not able to get the proper supply of the coal and they are not generating the power. Nowadays, and as per the yesterday's statement, because you need to know this, these are the current scenario, current affairs we call them. As per the yesterday's statement from the government, central government, they will be reducing the residential power distribution. Residential power distribution they are reducing. Only for industrial purpose or very, very important locations they are giving the power supply. Obviously, see our college. In college, I need a power supply. Minimal power supply is required for me. So everyone is, most of us are working people. Most of us. As of now, scenario is what happens. Everywhere working people only is available. Maybe 1/3 of the people will be staying in the home, the remaining 2/3 will be going for workplaces. So number of people who are staying in home is less, number of works going to be done in home is less compared to workplaces. So power should be given, distributed to the workplaces rather domestic. Domestic is house. So wherever the housing colony is there, they will be reducing the power distribution. After 10 o'clock, they'll cut the power. Till 3 o'clock, 4 o'clock, 5 o'clock, they'll cut the power. Whatever the power they are saving there, they are distributing that one to industries, which are very, very essential. Even there is a statement, it's a rumors, not yet come. For malls and all, they are going to give the clear instruction. They are not supposed to use huge power. Everywhere, every corner, they are going to put a lights in malls. Correct? No? Everywhere lights will be there. Just one second. See, my suggestion is always read newspapers at least 5 to 10 minutes, not more than that. Headlines you should know. Headlines. What is happening in current scenario? It may be good or it may be bad. If you go in depth, no, you will concentrate or don't go for that one. Some of the unwanted news also will be there. My requirement is this is industry or academics related, anything is there, you can go for it. Even there's one good news for scholarship got held, and the ministry yesterday clearly they have stated that when all the scholarships should be released instantly. Till now, last year they have not released the scholarship. Now they need to release the scholarship over there. So this is going to be a good news for the students, those who are expecting the scholarships. Like this, schemes are there. Lot of schemes are available, government schemes are there. I want you people to apply for that one which is applicable for you. Especially girls, there are a lot of benefits. You should search for that one. You should search for that one. State government is giving a lot of facilities. Central government is also giving a lot of facilities. So you have to search, make use of them. They may be giving you some internship, they may be giving some incentives, they may be giving some scholarships. Their education, especially for girls, free of cost, they can do the education. If you really search those websites properly. I insist, government is giving all the facilities, but we are not using them properly. So go for it. So coming back to the topic, power is now current scenario, power is required everywhere. Even vehicles, they require power. So power requirement is more, generation is less, and we are having a very important role of how exactly power can be generated. There is a thermal power is there, there is a hydro power is there, there is a solar power is there. Using gas also you can generate the power. Have you heard about using gas we can generate the power? Yes, you can generate the power. Using gas you can generate the power. So 4 different power generations are there. Using them, whichever is required for our electronic circuits, we are going to make use of them. Power generation is very important. After generation, you should transmit it to the proper location, then distribute it. Distribute in essence, distribute to domestic, distribute to industry, distribute to commercial. You have to distribute them itself. So power generation, power transmission, power distribution, then consumption comes into it. Consumption. So we should consume it properly. We should consume it properly. See, in the classroom, hardly we're having somewhere around 30 to 40 students are there. Switching on light is not required. But people simply come and blindly they'll switch on the lights over there. Though it is not required. Sometimes it may require over there. If the sunlight is very dark, there is no sunlight at all, at that time, not always. So consume less. Okay. Electronics deals with the study of solid state semiconductor power devices and circuits for power conversion to meet the desired control objectives. This is the topic what we are going to study. Electronics deals with the study of solid state semiconductor devices, that to power devices, and circuits for power conversion. How exactly we can convert? That is, generally we get AC power, alternate current, but our electronic circuits require DC power. They don't require alternate current. Our mobiles, they don't require AC. If you give AC, your mobile will be burned like anything. It will become ash. You need DC. DC 3 volts, DC 5 volts. Have you ever looked into a charger? Charger? Read the instructions over there. In that one clearly it's mentioned input voltage is this much, output voltage is this much. Even in output voltage also it will mention whether it's AC or DC. Current also it will mention what is the current it's going to get. So it's a pure rectifier. Your charger is a pure rectifier. What rectifier will do? Converts AC to DC. Correct? Even my charger is here, laptop charger. This is a charger. What is my laptop requires only 15 volts DC. I don't require AC. So it's converting AC to DC. It's just a bridge wave rectifier what we are having here. A bridge rectifier, but since 230 volts need to be converted 15 volts, and this is this much size. But your laptop mobile chargers are only this much size it will be. Okay, depending on the requirement. And I insist you don't use the chargers whichever you find it. Use the proper charger for that particular mobile itself. If you are having Redmi, that particular charger only you should use. Don't use the Samsung because the power what it's going to give is going to be different. You can check it out. You can check with each and every chargers. This charger totally is different. This charger output is going to be different. Okay, and your mobile with the proper charger only you have to go for it. So this is semiconductor devices, power generations, and circuits for power conversions to meet. Power conversion is AC to DC, DC to AC. We are going to convert them. Control objectives. Power electronics may be defined as the application of solid-state power semiconductor devices. Solid-state semiconductor devices, purely called as thyristors. That is the actual topic what we are having in our syllabus. Okay, solid-state semiconductor devices. They are called as thyristors for the control and conversion of the electric power. We are going to using my simple diode circuit. Simple diode, I can convert AC to DC. There is power conversion. Simple BY127. I think you might have heard about BY127 as the diode name. A green color diode. Have you ever seen the diode? Have you ever seen the diode? Yes or no? This is how it looks. This is BY127. This one. BY127. This is different. Black color one is different. Okay. Anode and cathode you can easily identify. Anode and cathode. See, everything only theoretically knowledge is not sufficient. You should know, you should feel that how it looks. BY127 is a diode which is meant for generally it's meant for switching. Okay, it's an anode, it's an cathode. Diode will be an anode and cathode. So the flat face, what it's a flat face, that is anode. The round face, what we are having, the round shape, that is cathode. Flat is anode, round is cathode. Even you can see here, clearly it's mentioned. This is flat face, bottom, that is anode. This is cathode. And now we go for one more type. This is one more type. It's a black color, it's going to be. Here, both the sides we are having flat only. Both the sides we are having flat spaces only. Both ends. Here also flat, here also flat. It's pure cylinder, cylinder-like structure. It is not a resistor. It's a diode. But the problem here is how to identify anode and cathode. Full black side, it is anode, and a ring, gray color ring is there. That is a cathode. Gray color ring what we are having, it is cathode. So BY127, it's a green color where we are going to have a rectifier. Easily we can identify anode and cathode. But with the black color diode, both it's purely cylindrical size where it's going to be used as a switching circuit. You can switch AC to DC, you can convert, or you can switch on, switch off. Okay, switch on, switch off also operation is going to be. So we will be, and see here. This is one more. Here also, you are going to see this is black. Here little bit gray color is there. Gray color is there. Gray color is a anode. Sorry, cathode. Gray color indicates cathode. Whichever the side gray color is there, ring is there, that is cathode, and pure black is going to be anode. So many types of diodes are there. different vendors, they are manufacturing in different shades. Okay, here also black color is there. See here, this also a diode. BY127 high voltage silicon diode. It's mentioned flat surfaces, anode, round surfaces, cathode. Okay, because we don't find positive, negative, positive, negative. We don't find. So anode and cathode only we should know. What is positive? Anode means positive, cathode means negative. So how to identify? You can easily identify that. See BY127, everything you can easily find. This is one more I would like to show you. D1M400. See here. This is one more diode. BY127 is one diode. Okay. Behind diode symbol. You know the diode symbol? Arrow with a line. Okay. Vertical line. So this is anode. This is cathode. Here also pure black color is anode and a gray color ring is a cathode. Easy. Everything you can Google it. I am here to just to show you the path. Where exactly you have to show that you have to search for that. You can search. You can search anywhere, you can search over that. So UJT, VJT, everything you can search online itself. Okay. But my duty is what it is and how to search for that. Now, power electronic deals with the study and design of thyristerized power controllers for a variety of applications. Thyristerized power controllers. It's a thyristerized silicon control rectifiers. There is a power controller. It's going to control the power transmission or power consumption, everything. There, our major duty here is duty of the power electronics is mainly to deal with which device require what type of power. Which electronics require circuit requires what type of power it's going to be. Some of them they require AC voltage, some of them require DC voltage, some of them they need to convert AC to DC, some of them they need to convert DC to AC, some of them they need to convert higher order AC to lower order AC. I mean some 200 AC, I need to convert that into 100 AC. Conversion. It's not that AC to DC only. AC to AC also you can convert. That is step down, we'll call that. Step down. You might have done this one in your first year, sorry, basic electronics, half-wave rectifier. In half-wave rectifier, a transformer you are going to use in the input, and at the input side it's going to be 230 volts, at the output side it's going to be 12 volts. It's a 12 volts AC. That 12 volts AC you are going to convert that into DC. Correct? Initially 12 volts AC, the 12 volts AC you are going to convert that into DC. So, convert AC also possible, AC to DC also possible. Similarly, DC to AC also it's possible, DC to DC also it's possible. 4 combinations. Power electronics deals with the study of design of the terrestrial power controllers for a variety of application. Heat control, light illumination control, motor control, AC or DC motor device drives used in the industries. Any industries. There are so many industries that deal with the motors, machines. Machines need to run. Okay. So if they want to run, a simple example is your elevator. Elevator, heard about it? Yes or no? Elevators are there. Elevators need to work, moving up and down. How exactly they're going to move up and down? There should be a motor. Motor has to take care of pulling it up and pulling it down. So motor has to work. If the motor has to work, whether it is a high voltage, high requirement, some of them are high voltage and requirement. If you go to this one, good. Here you can find grinding machines and all. Okay, where grinding machines require very high power requirement. Okay, 1 HP, 2 HP, 3 HP, like that, they're going to call that. Okay, so there high voltage is required for that. Even our transformers, what which is installed in the roadside, there are very high voltage. Power generation generally from the generation station, it will be in the form of kilovolts. Power generation, it will be in the form of kilovolts. Like Sharavati power generation station is there, and Shimsha power generation station is there. I told you RTPS. There is a Raichur power, thermal power generation. All these, they are generating the power in terms of the kilovolts, like 66 kilovolts, 11 kilovolts. You might have seen the high tension wires in fields and all. If you are passing through the fields, you will be seeing the high tension wires. There are 11 kilovolt voltage is there. 11 kilovolt. But the power what we are using here for light and domestic purpose, we are using 230 volts. It is just 230 volts, but the generation is kilovolts. Okay, so the transformers what it is installed in the roadside, they are having 440 volts. 440. Generation is 66, transmission is 11 kV, but transformer is 440. Domestic purpose we are having 230. They need to be stepped down. 66 kV to 11 kV, 11 kV to 440, 440 to 230. They need to, that is conversion, we call that one. They need to be stepped down. Step down is also one type of the conversion only. Okay, so AC motors, DC motors just like a toys. But the toys we are using, robots, they are using toy. It's a toy, robot is a toy. It has to move. So turn left, right, okay, turn his hand, legs, all those it has to do. So there we are going to use the DC motors. It should keep moving. Okay, eye has to be rotated. If eye has to rotate, the head has to rotate like this. It's a motor there fixed over. They are all called DC motors. AC motors are very high speed motors. But grinding machines and all what we are going to have, or your washing machine is going to rotate with a high speed, RPM, rotations per minute, we call that. So there are vehicle propulsion system, high voltage direction current system. Even vehicle also, simple vehicle if you say it should rotate, the motor has to be there. There are high voltage motors. That is what we are going to study. Now, the first power developed was the Mercury arc rectifier during the year 1900. Generally, I think you will have come from Chikbalapur. Who is the father of electricity? Especially for Karnataka, who is the person who has given power supply? You know? A person, because of him, we are able to get the power supply. A person who has designed and constructed a power generation stations, Sir M. Visvesvaraya. Because of him only we could able to get power supply to the Karnataka. Asia's first power generation station is established because of him. Because of Sir M. Visvesvaraya, he could able to see Sharavati Falls, Jog Falls, and he could able to see there is Gaganchuki Barchuki Falls near Mysore. Okay, and he was thinking this much energy is getting wasted. We should make use of this. With a very high speed, the water is falling from the top to bottom. We are not making use of it. So Sir has thought with this we can do something. The energy is very high. So he thought of generating the power with his concept. With his concept is we have developed, means our country has developed a power generation station that is hydro power. Using water we can generate the power. In Jog Falls also they are running on hydropower. Shimsha also running on hydropower. Nowadays, even any small falls, waterfalls is there. No, there also they can generate the water power. Okay, we are having wind energy also. Through wind also we are able to generate. So my point here is, previously when Visvesvaraya sir was there, at that time they were not having electricity. They used to use the lamps, oil lamps, to study whatever the activities they want to do. So with that one only they studied and they could able to achieve some milestones and they could able to serve the society. Now we have to think in their angle. Sir is from our state. He has contributed a lot. He has lived for 100 years and his contribution is limitless. There is no limit. All the corners he has served. Like building the dams, civil engineer, basically civil engineer. dams he has constructed, planning he has done. In Bangalore, many areas have been planned by Vishweshwaraya sir. Jayanagar area is totally planned area. Because of him, Jayanagar is still, it is good. Other areas were not planned properly. Simply they have laid out. But Jayanagar area basically, Vishweshwaraya sir has planned it. This should be the size of the road. This should be the size of the layout or house sites. This is where the park has to come. This is where the your playing ground has to come. Everything he only planned it. So before, when they were studying, there was no hydropower, there was no electric power they were having. So at that time, initially, how to generate the power? They were generating the power using electric arc, that is mercury arc rectifier, power electric device. The first power electric device developed was the mercury electric arc rectifier during the year 1900. The other power devices like metal tank rectifier, grid control vacuum tube rectifier, ignition, panatron, once they came to know that one, yeah, there is electric power can be generated. With that one, you're able to operate create some devices. They could keep on developing that. Now, just 15 years back, there was no mobiles. Because of the frequencies what we are able to get, they find out, yeah, frequencies are available. We can make use of the frequencies. Using frequencies, we are able to communicate. They were developing the mobile phones. Using mobile phones, they are able to. Previously, it was a wired communication. Now wireless communication they are doing it. So like this, every day innovations are coming into picture. So once the electricity comes into picture, they could be able to develop all these rectifiers, grid control vacuum tube rectifiers. At that time, vacuum tube. I told you vacuum tube only. They were not having semiconductor devices, vacuum tubes. Then ignitron, panatron. If you want to know in depth of them, just go and give their name. What do you mean by ignitron? What do you mean by vacuum tube rectifier? You'll get the images. See, simple. We don't have these things in our college. If you come and ask me, sir, can you show me the vacuum tube rectifier? It is not there in our campus because we are not used to. You can see the image, or you can find out the any videos if they've performed. You can see how exactly vacuum tubes are working. Videos, small videos, you can go for it. Animated videos, you'll get that. So you will gather the knowledge how it was working previously, how we are working now, how technology has been developed. Very book just go beyond the book also. I know it consumes time, but nowadays since it has become online, everything can be easily we can get that. Beyond the syllabus, beyond the contents, we can get that. So this is your vacuum tube, see anode, cathode, all those things were there. Okay, you're able to get that one. We have studied this. When we were doing our BE, at that time, vacuum tubes we have studied. What is anode, which one is anode, which one is cathode, everything we have studied over. In between a grid also was there. The first SCR, silicon controlled rectifier, or thyristor, any name, is developed in Bell Labs, okay, in 1956. Easy to remember. Can you recall what is 1956? What is why that year is very popular? Yes. Okay, no issue. 1956, 1947, 1950, 1956. Six years after Republic. Okay. So it is 40 years before I born. Like that I say. 40 years before I born. 50 years before I born. Like that. That is BC. Your name? Rita. 50 BC Rita. You can say that. Correct? No? Just don't take it seriously. 1956. Where are you from? You are from Bangalore? Born, brought up in Bangalore? Srinivasapura. Where is Srinivasapura? No, no. Ask. So only one girl saying in Aston, others are day scholars. Okay. 1956 is a very, very important year for Karnataka people. Karnataka renamed. We are separated. Renaming is different. We are separated. South India has been segregated as Karnataka, Andhra, Tamil Nadu, Kerala, like this. 1956. Kannada Rajyotsava. Sir, we are all from English medium. We don't know all those things. We know only 26. We know only 26. We don't know 50. Correct? ಅದಕ್ಕೆ ಹೇಳೋದು ನನ್ನಂತವ್ರು ಇರಬೇಕು ವಯಸ್ಸಾದವ್ರು ಇರಬೇಕು ಅಂತ ವಯಸ್ಸಾದವ್ರು ಮನೇಲಿ ಇರಬೇಕು ಆವಾಗಲೇ ಎಲ್ಲಾನು ರೀಕಾಲ್ ಮಾಡ್ತಾ ಇರ್ತಾರೆ. ಓಕೆ, ಸೊ 1956 in Bell Labs this year have been invented. So it is easy to remember. So I always relate. It's not that I simply go explain a text which is there on the where you can easily catch them. Sir was telling something 1956, in 1956 something. You can easily recall that. So that one statement, if you put no, you will get one mark. If somebody asks you when the thyristor has been manufactured, this year has been manufactured, easily you can recall that one. 1956, Karnataka got in this one separated, free from all the other states. Okay, the second electronic revolution began in the year 1958. As soon as always, generally it happens. Generally it happens. Assume that one for only for the first time we are going to struggle. Only in the beginning we are going to struggle. Once we got the output, immediately we'll try for the next one. Okay, immediately. Redmi, simple example I can tell you. Redmi, once it comes into picture, once it comes into market, they struggled a lot. Once it is got popular, immediately they release the next version. After every 1 year, they go for the next version, because they came to know that the market is very huge. We can sell our products. Similarly, till 1956, they struggled a lot from 1950. 1950 to 60 years, they struggled a lot. Once 1956, they came to know that yeah, thyristors are playing very important role. Immediately, the next year, they will come up with the next one. Okay, so 1958, huge revolution has come into picture with the development of the commercial grade thyristors by the generic electronics. General Electronics, GE. You might have heard about Philips, Sony, LG, all those things. GE is the father of all these things. General Electric, okay, company. Father of all this is a very, very old company. Okay, so thus the new era of power electronics was born, 1958. Okay, after 1956, after that many different types of power semiconductor devices and power conversion techniques have been introduced. Obviously, ಒಂದ್ಸಲ ನನಗೆ ಗೊತ್ತಾಯ್ತು ಅಂತಂದ್ರೆ ಆನ್ಸರ್ ಬರೆಯೋದು ಇಮ್ಮಿಡಿಯೇಟ್ ಬರ್ಕೊಂಡು ಹೋಗ್ತಾ ಇರ್ತೀನಿ. ಇಲ್ಲ 3 ಗಂಟೆ ಆಗಲೇ ಗೊತ್ತಾಗೋದಿಲ್ಲ. ಕರೆಕ್ಟಾ? Once you know the paper, the first question, if you are able to answer, definitely you will come to know that one. Yes, this paper I can write it. That is what has happened there also. Okay, they were doing, they could able to get it. Time up, 220, 221, you know, 132, 220. Okay, last statement. The power revolution is giving us the ability to convert, shape, and control large amount of power. So we could able to convert. So last minute, sir. Okay. So any doubts? No doubts. My suggestion is